Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about what is random process and what are the temporal characteristics of the random process introduction. The concept of random variable, the computation of the statistical averages of single random variable and multiple random variables is studied in previous chapters. The application of these concepts to a communication system helps in theoretical study of its noise performance. Since noise in a communication channel is assumed as a random variable, in a communication system, the signal transmitted from the transmitter, that is S of t, and the noise available in the communication channel, that is N of t, both are found to be functions of time. In a communication system, the signal transmitted from the transmitted signal is denoted by S of t, and the noise available in the communication channel, and it is denoted by N of t. Both S of t and N of t are found to be functions of time. The study that was made in the previous unit is only about noise as a random variable only. Since noise in the communication channel is determined to be a function of time, that is n of t, it becomes necessary to study about a random variable as a function of time, which is referred to as a random process. The concept of random process. The random process is also called as a stochastic process. Random process is also called as a stochastic process. So the concept of random process is an extension of a random variable. A random variable that is a function of time is called a random process. So that is the definition of the random process. Once again, the random process is also called as a stochastic process. The random process is an extension of a random variable. A random variable that is a function of time is called a random process. So the random variable, and what is a random variable and what is the random process? The concept of the random variable is already studied in previous chapters. Okay. Now that random variable is an extension of the random process is an extension of a random process. That random variable is a function of time. It's called the random process. The random variable is a rule for assigning a real number x of lambda to each and every outcome of an experiment. That is the definition of the random variable that is already studied in previous chapter. Now here we are studying about random process. Now we define a random process as a rule for assigning a real valued function of time. That real valued function of the time is x of t comma lambda to every outcome of the experiment. So this family of functions is called a random process. This family of functions is called a random process. So that is the definition of the random variable and random process. The random process is defined as an ensemble or collection of functions of time. Ensemble or group or collection of functions of time. So with a probability measure associated, it is usually denoted by the random process is usually represented by or denoted by x of t comma lambda or x of t comma s are simply denoted by x of t. So mathematically or symbolically, the random process is denoted by simply x of t. The function x of t comma s or x of t comma lambda is also sometimes called a sample function or member function of the ensemble. So now here where capital X is a random variable, capital X is a random variable, S or lambda represents the possible outcome of an experiment. So these are the different definitions of the random process and symbolical representation of the random process. For example, For example, okay. So now here in this graphical representation, I am going to define difference between random variable and random process. The difference between a random variable and a random process is that of a random variable that the outcome of an experiment is mapped into a number. So random variable that the outcome of an experiment is mapped into a number, that is S1, S2, S3 like that. And whereas in for a random process, the outcome of the experiment is mapped into a waveform. So that waveform is a function of time. So this graphical representation is the difference between random variable and random process. Next, coming to the example of the random process. So consider a temperature example. Assume that we want to establish the statistics associated with temperature in a certain room. Let the temperature, capital T is the random variable. The random variables are denoted by uppercase letter. So now where capital T is the random variable, there is a temperature example. Let the temperature to be the random variable, capital X, since it may take different values on different days. Takes different values on different days. Its values should be recorded for many number of days. Since the temperature varies from say morning to evening in one day even, values are to be recorded for different times in one day and also for many days. Once again, capital T be let the temperature capital T be the random variable. Since Since it may take different values on different days, its values should be recorded for many number of days or single day. Since the temperature varies from says that varying with the temperature saying from morning to evening in one day even, that values are to be recorded for different times in one day and also for many days. Thus, the above random variable capital X is a function of time and can be expressed as x of t, which is a random process. So this is a good example of a random process.